So we're here with the Holst Centre, and who are you?
Hi, my name is Helen Cardon. I'm a business developer at Holst Centre. Here we are working at flexible freeform electronics.
So what are we looking at here?
So here is a flexible, partially stretchable display. This is the front side of it, all based on LED technology. We're looking at how to design and assemble the electronics on the flexible foils, and also validate it into an application level. Besides LED, we are working on OLED technology. So here is a high brightness OLED that you can see that we can go from low luminance to high luminance. Furthermore, we're looking at semi-transparent OLED.
Whoa. So this is for, what is this for?
So this gives opportunity that you can integrate light on transparent substrates. It can be a glass in a house or in a car or other locations. You can even design it to light up as a logo. For example, it's very thin and flexible and homogeneous. So it's very the other side of the LED.
It's really cool.
Yes.
What is the Holst Centre? What does it mean?
So Holst Centre, the name comes from Professor Holst, that is an old R&D manager at Philips in beginning of the 20th century. But Holst is a brand for innovation between two mother companies, TNO, that we are presenting here, and IMEC from the Netherlands.
IMEC is very famous research institute, right?
Indeed, and TNO as well. So IMEC is focusing on developing algorithms and electronics, and TNO is a multidisciplinary research institute. We have our colleagues on 3D printing, but at our team we are focusing on freeform electronics.
So let's look at more. What is this one?
Before going to this, I would like to mention that we are looking at freeform electronics, so electronics that can be printed on stretchable substrate. So we're looking at characterization of ink, substrate, and integrating a silicon-based component on a stretchable. Okay. Also skin-like very thin foils, for example, for medical applications. Furthermore, we're looking at integrating those on hard surfaces. So this is an example of a very interesting topic, is structural electronics or Inmode Electronics. Here you can integrate lights and sensors, for example, touch sensors on a hard substrate. So all the electronics are fully integrated.
All right.
Here you can see a slider.
How do you integrate it like that?
These are integrated based on thermoforming technologies. So you print and then form the electronics into a shape that you want.
Is this partnership with DuPont or no? It's just
so DuPont is one of our partners in that application. Yes.
So IMEC is like thousands of researchers, right? It's very big, and is European or worldwide? So
it's. I would like to mention again, IMEC is part of Holst Centre. So TNO and IMEC has established Holst Centre. So at the TNO we also have around 3,000 researchers working on different topics.
And all this is getting commercialized? When can I buy this is a flexible OLED?
No, this is a flexible OLED display.
Display?
Yes, so it's a rollable, foldable display that, for example, you can see in your mobile phones these days.
So when can I have a smartphone with this? What is required now before you can mass produce and commercialize and make a lot of money for the Holst Centre?
So we're working with partners in the industry. We don't produce it ourselves or manufacture it on a high volume, rather on a prototyping level. But we have partners in our network, that ecosystem, that they are looking at mass manufacturing this sort of technologies.
Nice.
More of that, then we are looking at printed sensors. That is a very interesting topic because the more you can print, the more flexible becomes your systems. One of the printed sensors that I would like to introduce is the house patch technology. Okay. So we have developed ECG sensors that can be, the patch can be worn on body for up to 7 days. It's very flexible, formable. It doesn't produce any screen irritations because we look at biocompatibility of products. It acquires medical grade data for about breathing rate, heart rate, and movement, and for example, could be used for patient monitoring. Besides ECG, we're looking at other source of sensor.
What do you have connected in here?
Yes, so these are our printed pressure sensors and temperature sensors. This is an example of it. So we can print sensors in a very free form, and they are stretchable, formable, and very accurate.
This one is pressure or no?
Yes, but so the black dots are the sensitive materials that react to pressure, or we have another sort of temperature sensors.
Is it connected now?
Yes, I will show you. So for example, this is a one-node temperature sensor that reacts to the temperature. The temperature sensor is very unique recipe. It becomes very sensitive to the temperature differences. I show here our temperature sensor, but I have a very cold hand, so you might not see it very well, but it reacts right away to my palm. Can you see my finger forms here? So it's very sensitive. The other technology we have is a pressure sensor. So if I put my hands, you can right away see. So we can use these pressure sensors, for example, on top of mattresses for patient sleep monitoring, or other applications, shoe inlay, and for movement, posture management type of applications.
And we need to see all your sensors in close, right?
Yes.
So what is happening with this shirt here?
So this is the third generation of our ECG monitoring shirts. So the electrodes are printed on top of the substrate and laminated on textile. So you cannot feel it. It's very stretchable, soft, and washable. And you don't need to have a very tight skin contact to measure all the biometrics. Yes.
That's awesome, right? Why don't we? Why isn't there like mass production of this yet? How long it takes?
Depends on if a company would like to invest in further developing this mass manufacturable product.
And then you just there's a procedure to take this research kind of stuff into mass production. There's a procedure. There's
well, the technology is mature enough for being produced in a high volume. We have in our ecosystem companies that can manufacture these units. So it comes to the end user who have the creative idea to bring it to the market.
And let's check here. What is TNO showing off here?
So TNO here is a company that one of the teams at TNO focuses on printed 3D printing. Yes, of course.
But not necessarily ready.
So how is this made? This is very intricate 3D printing.
Make a pause here because I'm not a specialist.
Service, so they can test it out.
Let's go over here. There's some 3D printing of teeth and
then the second part.
Right there. Lots of stuff going on here with the 3D printing.
I have to call my colleague who's a specialist here.
When they want to move to
maybe we can just grab a couple of these.
The process
take them out.
Right now very manual.
And there's a lot of
so you're also working towards making more industrial. So we also have
we
new
are
industrial
3D printing stuff happening here.
Building a software solution to manage the process.
Okay.
Design.